Okay, we had a excuse me, we had a slight interruption in the recording process. So I hope I'm continuing from approximately the same place where we left off. So let me pick the pointer first. So we we were in the process of discussing the full join, or as it's sometimes called the full outer join. And what the full join does, you can see in the definition that we discussed a little while back. A full join shows records from both tables, both the records that are related as well as the ones that are unrelated. Remember, we're joining two tables at the same time. So any one join will always join two tables. And in a full join, we show all the records from both tables, those which are related and those which are unrelated. So let's apply that over here. So here is the join statement. So we say select f dot star comma o dot star from such and such. So these two columns over here, f dot star means select all the columns from table F. So F is an alias for the faculty table. O is an alias for the course offering table. All right. So f dot star means all the columns from the faculty table, so both these columns. O dot star means all the columns from the offering table. That means both of these two columns. Okay, so right off the bat, as soon as I see these two, I know that in the output, this table is the output, we'll have four columns, two from faculty and two from course. So that takes care of this, the select columns. Now let's look at the following clause, the from clause. It says from, here's the first table, here's the join, and here's the second table. A join always connects two tables. So the first table and the second table, right? And the type of join that we have, the different types of joins. The type of join that we're executing now is full join. Once we have told the software that, hey, I want to do a join, joins always occur or are executed based on common fields. Remember earlier on when we discussed the vendor example, it's foreign key equals primary key. That's the kind of connection that we're looking for. So look at the equality that's specified here. It says on these two columns. So it's saying, please join these two tables. Please join table F with table O based on these two common columns, equality of values for these two columns. So what are those? What's the equality we're looking for? F dot faculty ID. So F dot faculty ID equals O dot faculty ID equals O is this table dot faculty ID. So we're looking for matching faculty IDs in the two tables. Remember, faculty ID was a foreign key in course offering. It's a primary key of faculty. So now let's look at the outputs. There are 1, 2, 3, 4, 5 rows in the output. How did 5 rows show up? So let's look at the first row, which is 11111 John Doe. So we start with the first faculty member. Okay, it says faculty full join course offering F full join O. So this is the left side table. This is the right side table in the statement, not in this picture. This is the left side table or table 1 in the statement. So we start from faculty. The first faculty is 111 John Doe. So I write 111 John Doe over here, and I look for a matching faculty ID in the course offering because it says F dot faculty ID equals O dot faculty ID. And these two match. Do you see this faculty ID and this faculty ID match? So I pull out this record, MIS 301111, and I stick it in here. So that's how the first row was determined. Okay. So now I still am on this first row, John Doe, and I look at the other records in course offering, and the faculty IDs don't match. Okay, so I'm done with this fellow for the moment. Now I go on to 222 Maggie Smith. So here is 222 Maggie Smith. I look at the first record here, the faculty ID doesn't match, so nothing gets picked up. Now for the second record in the offering table, the faculty IDs match. Okay, so I pick up MIS 301 2222 and then fill it in here. That's how I get the second row. this Maggie Smith with MIS 301. Now I'm still at Maggie Smith, and I see that there's a match over here with MIS 310, the two faculty ID numbers match. So I have 2222 Maggie Smith, and I stick that next this matching course MIS 310 with 22 over here. So these three records are records that have been constructed by matching values from the two tables. Here's table 1, that's the faculty. Here's table 2, there's the course offering. And these three records are records that match across these two tables. They match based on these two columns. Okay, but we want this full join. What it says is, don't just give me the records that match, give me the records that don't match as well. Okay, so I want to know which course offerings are taught by which faculty. I also want to know which faculty have not been assigned to any course offering, and I also want to know which offerings don't have any faculty assigned to them. So I want the complete picture. Okay, so if I go down to this last faculty member, 3333 David King, so I put in 3333 David King over here, all right, and there is no matching value of faculty ID in any of the course offering. So I write null, null. There's no matching value for it. Okay. Similarly, if I go down the rest of the course offering and I find this last course number over here, it's MIS 320, and I look at the faculty, there's a null value for the faculty ID, so it doesn't match anything in the faculty table. Okay, so I write MIS 320 and null, that's this guy, and it doesn't match anything in the faculty table. So I have null, null, these two. Okay, so null and null, these two are. So that's how the 5 records are obtained. So I have in the output, I have related records between the two tables as well as unrelated records. So on the right hand side, you can see the legend over here. David King is the faculty who's not assigned to any course, and MIS 320 is the course that doesn't have any faculty assigned to that offering. Okay, and in the output, the first 3 records are faculty and course offering. Those are the records where we have matching values. And then we have a list of records in the first table that don't have a matching value. So this is faculty not assigned. And at the end, we have the records in the second table that don't have a matching value in the first. So these are the course offerings that have not been assigned to any faculty. Okay, so this is the whole picture that results from doing a full outer join. Now, in the following example, we will keep the same 2 tables, but we will execute the other 3 types of joins, namely left join, right join, and inner join, and see how, even starting from the same 2 tables, the end result is different. Okay? Okay, let's now see the same picture, but the only thing that has changed now is the left join. So now we are saying select F dot star all the columns from the faculty table, all the columns from the offering table, and join faculty with course offering on faculty ID equals faculty ID, F dot faculty ID equals O dot faculty ID. So we are still looking for matches between the two tables based on faculty ID. However, we are now doing a left join instead of an outer join. Okay, so what's the question that you would ask that would correspond to executing this left join? So here we're saying show all faculty and their offerings, include faculty who have no related offerings. So basically, I want a list of all my faculty, and for each of my faculty, I want to know if they're teaching a course, I want to know the course that they're teaching, and if they're not teaching anything, I want to know that too. I want to know faculty X is not teaching, faculty Y is not teaching, and for those who are, I want to have a list of the courses that they are teaching. Okay, so I start off the same way. Here is 1111. It says faculty left join course offering. This is the first table. Here's the second table. Okay, the left table and the right table. So I start off with 1111 John Doe, just like I did with the outer join. So here's 11 John Doe, and I look for a matching value for faculty ID. I find it here. with MIS 301, the faculty IDs match. So I put in MIS 301 1111. So for the same thing as what we did the last time. Now I look down the rest of the offering table. I don't find any other record where the faculty ID matches 1111. So I'm done with John Doe. Now I move on to Maggie Smith. That's 2222. And I write down 2222 Maggie Smith. And I start hunting for matches and faculty ID. The first row doesn't match. The second row, the faculty IDs match. So I pull out MIS 301222 from faculty course offering and I stick it in the result. So here is MIS 301 and 2222. That's how the second row was determined. Yeah. So I still park myself at Maggie Smith and I continue hunting the rest of the records in course offering. And I find another course that Maggie Smith is teaching, that's MIS 310. The faculty ID numbers match. So I put MIS 310 and 2222 in here. Fine. So now I come to my last faculty, 3333, David King. Remember, the question said, list all my faculty. If they happen to be teaching a course offering, list all the course offerings that the faculty teaches. If they are not teaching any offering, I want to know that too. So here is David King with the faculty ID 333. So I put 333 David King here. And I start going down the course offering table. I don't find any record for which the faculty ID matches 3333. So I put null, null for the two columns here. Okay. So this is the output of a left join. I hope you can see where this is different from the full. Well, the result is different from a full outer join. If I were doing the full outer join, I would take the next step and I would also list the offerings for which there is no assigned faculty, and there would be an extra fifth row listing this course MIS 320. So the answer is different. Same two tables. The only thing that's different is we're doing a left join instead of a full join. Okay. So now next we'll look at right join and inner join, the two other types of joins that exist. So now let's look at right join. The same two tables. So this time the wording of the question is slightly different. Show all offerings and details of faculty assigned to the offering. Include offerings that have no assigned faculty. So I want the list of offerings. For every offering, I want to know who's the faculty who's teaching that offering. If the offering doesn't happen to have a faculty assigned to it, in this case is MIS 320, I want just the details of the offering. Okay, so the select statement says select f dot star o dot star, same column. So the four columns are picked up. These are the two columns from offering. These are the two columns from faculty. This is from faculty right join course offering. Okay, so this right join points to course offering. It tells me that I want all the records of course offering, whether or not they have matching values. Okay, so if I compare that to the left join, when I see a left join, the way I interpret this is I want all the values of faculty, those that match offering and those that don't. Okay. So now let's look at the right join. So I start off with the first faculty. It says faculty right join course offering. So I start off with with course number over here. So here's MIS 310 1111. Okay, and I look at faculty, which faculty teaches MIS 301. Here's the faculty ID number that matches. So I have the first row, and it's the same logic for the second row. I'm matching Maggie Smith with MIS 301. I match Maggie Smith with MIS 310. So far, these three are the same as what happened with the outer join, are the same as what happened with the left join. But notice the difference now. If I were doing the left join, I would have wanted, if I'd been doing a left join instead of a right join, I would have wanted a list of all the faculty, whether or not they were teaching course offering. If they were teaching a course offering, I would list the offering with the faculty. If they were not teaching a course offering, I would just provide the details of the faculty. That's what we did with the left join. Now with the right join, I don't look at David King. Okay. So David King doesn't have a matching course offering. So now I want a list of all the offerings that don't have a matching faculty, because it says it's a right join. This is the right table, the right side table. This is the left table. F is the left side table. O is the right side table. So when I say right join, I want all the records of the right side table, the course offering. If they have matching values, provide the matching value. If they don't have the matching values, then you don't say null for it. Okay. So here for this last row, here's MIS 320 null. That's this record. It doesn't have any matching faculty, so this is a course for which there is no matching faculty. Hence, I have null and null for the faculty name, f dot faculty name and f dot faculty ID. So I hope in this, you can see that with the left join and the right join, in this case, in both cases, we have the same number of records, but the nature, the content of the record, last record is different. Okay. So if you compare the outputs from the full outer join, the left join and the right join, these first three records were the same. Okay, it's the remaining records that are different. Try to flip among those three examples and just assure yourself that you figure out why the output, what was the mechanics behind creating those three different outputs. Okay, so now we'll proceed to look at the very last type of join that we have, which is the inner join, which is by far the most common type of join that's used. Okay, so here the question says, show me the faculty and their course offering where there is a match. Okay, so only include related records. If there is a faculty who's not teaching anything, I don't want that faculty's record to appear. If there is a course offering for which there is no assigned faculty, I don't want that in the output at all. So in the output, I only want course offering along with the associated faculty when there is a match. Okay. So how would we write this? We say select f dot star, comma o dot star. We pick up all four columns from these two tables. And I say from faculty join course. So same sort of, here are the two tables. Please join table F with table O. Faculty is the left side table. Course offering is the right side table. And we are instructing the software to join these two tables on the common column, common field, f dot faculty ID, which is this fellow, and O dot faculty ID, which is this fellow. Okay, so we are connecting based on common values for these two. So I start with John Doe. John Doe 1111 matches MIS 301. That's what I have over here. The faculty IDs match for the first record over here. So I splice them together and I get the first row of the output. 111 doesn't match any other course offering, so I'm done with 111. I look at 222. 222 matches MIS 301 and it matches MIS 310. That's how I got these two records. I don't bother about David King because this particular faculty has not been assigned any course offering. So you don't see a fourth record which says David King. Flip side is I have MIS 320 as a course that has no faculty assigned to it. So I don't bother about putting that in the output. Okay, so the output only consists of matching values from both tables. Unmatched values are not included in the output. And 90% of the time when we do a join, it's an inner join. So if it just says join, then it's an inner join. This is the kind of matching where we pick records from related value, related records. Only when the foreign key and primary key match, only then we pick up the associated records. Okay, so these are the four different kinds of joins that exist. And please take your time and review the differences among them. As we said, 90% of the time you'll be doing an inner join, but once in a while, depending on the question that's been posed, that the type of extraction that you want to do, you may need to do a left join or a right join or an outer join. Okay, those three are the much less commonly used joins. This inner join is by far, as it may be, hazarding a guess, 90% of the joins are of the inner join variety. Now let's look at a little nuance here in terms of writing the equivalence of different joins. So let's look at these two statements over here. Both are join statements. Okay, select f dot star o dot star from something. select f dot star o dot star from something. Okay. Now in both cases, in both these two commands, we are joining based on the common values of faculty ID. Foreign key equals primary key. So we are joining based on this equality of these two columns. So this column and this column, then we're joining based on the equality of that. What's the difference between these two commands? In one case, I'm saying left join. In the other case, I'm saying right join. Okay. However, notice that we have flipped the sequence of the tables also. So in the first case, we are saying select these 4 columns from faculty left join course offering. So when you see a left join, you want all the records of the table on the left. So a join always connects 2 tables, right? So when you write the command, there is a table on the left and there's a table on the right. So when you see a left join, what you're implicitly telling the database management system is, please give me all the records of the table on the left and those that are matching in course offering. And even if there is not a matching value in course offering, please give me all the values of it. Okay. So this is the left table, this is the right table. Okay. Now let's look at the second one. It says right join, but we have also flipped these two. Okay. So it's a right join course offering right join faculty. So we are saying please right join O with F. Okay. And remember, in a right join, we want all the records from the table on the right of the join statement. So do you see in the right of this statement is still faculty, isn't it? Left join with faculty on the left, right join with faculty on the right between these two tables. The output will be exactly the same in both cases. Okay, so this is the equivalence of it. So when you do a left join and a right join, the sequence in which you write the two tables matters. And in this case, between these two examples, the left join and the right join, they both give the same output because we have flipped the sequence in which we write the two tables. F left join O is the same as O right join F. The results will be the same. So this equivalent of these left and right joins is something to keep in mind. Also, it just implies to you that the sequence in which you write the two tables will affect the contents of your output when you're doing a left join or a right join. Okay. Now we'll end off with a discussion of the more complex type of joins. So with the vendor example, I showed you an instance of a question which would require you to connect 3 tables together. So there can be queries where you're trying to connect 4 tables together. Any one join will connect 2 tables. So if you're connecting 4 tables, you will need 3 joins. If you're connecting 3 tables, you will need 2 joins. All right. So a join connects only 2 tables. So what happens when you're trying to do multiple? You're trying to join multiple tables, 3 tables, 4 tables, 5 tables, and so forth. Just joining multiple tables together. How does that work? You would do it using joins, of course, but how does the sequence of joins work when you have multiple tables? We'll try to take a little look at that now with examples. So here's the general rule to apply when you're doing multiple joins. So here we have 3 tables. We want to join 3 tables together. Of course, we can only join 2 tables at a time. So we join A with B and we join with C. So this is how it's written: A join B join C. Okay. However, the way in this works is you first do the first join. So you join A join B. That gives you a result. Then you take that result and join it with C. So the result, the result of first join, A to join B, let that result be result 1. Then in the second step, you take result 1 and join it with C. What is the output of each join depends on the type of join that's being used. Is it an inner join, a left join, right join, full join? Okay, so you saw from the 4 examples that we just discussed that even though you have the same 2 tables, depending on the type of join that you're using, the results are different. Okay, so that concept will apply again over here. All that this statement is saying is, if you're joining multiple tables together, you join the first 2, that gives you 1 table. Then you take that resulting table, you join it with the third. That will give you yet another table. If you have 4 tables to join, you would take that intermediate result and join it with the 4th table. That's the sequence in which you would do things. Let's take a look at how each step would work in the matching and going forward. Okay. So let's say we have now A full join B. So in table A, we have 1, 2, 3, 4, 5 records. In table B, we have 1, 2, 3, 4, 5 records. So this is slightly misaligned. So this B1 should be here, B2 should be here, B3, B4, B5. Okay. So this line means, remember, for all the join examples that we saw, we always specify what is the matching field, what are the 2 columns that must match in order for the records to be joined. So these lines that you're seeing over here simply tell you which records have matching key and matching values, primary key and foreign key that they match. Okay, so A1 matches B1 in terms of the primary and foreign keys. A1 matches B2 in terms of his foreign key, and A2 also matches B2 as the foreign key. So let's say the first step we're doing is A full join B. Remember, we're looking at multiple joins. Now it's more than 2 tables, and we do it as in steps of 2. We join 2 at a time. So let's the first step, A full join B. So remember what how full join works. It gives you records that match for the 2 tables. It also gives you records from A that don't match, and it gives you records from B that don't match. So it gives you everything. So let's see how that would work. So A matches B. So the first output that we would get is A1, B1. So remember, we stick the 2 records together. So A1, B1. Why? Because of this match. The next record that we would get in the output is A1, B2, because these 2 match. Okay, here is your A1, B2. Now I would get, the next one I would get is A1, B2. That's this line. I'm sorry, A2, B2. That's what we would get over here. A2 is the second record in table A. Okay, so A2, B2, here we go. So these 3 records in the output are the results of matching values between the 2 tables. But a full join also includes unmatched records from either table. Okay, so here we have A3 null. So A3 does not match any record in table B. So we say A3 null. A4 doesn't match anything in table B, so we have A4 null. A5 does not match anything in table B. You don't see any line from A3 connecting to anything in B. So we have A5 null. So we are done processing the unmatched records in table A. But we're not done yet because this is a full join. So we have to look at the unmatched values in table B. So for table B, I have, here's B3. It doesn't match anything in table A. So I have B3 null. Similarly, I look at B4 in table B. It doesn't have a line connecting it to any other record in table A. So B4 is unmatched with table A. So here I have B4 null. B5 has no matching value, so B5 null. So this table 1, 2, 3, 4, 5, 6, 7, 8, 9. So the output table of doing a full join between A and B, it consists of this 1, 2, 3, 4, 5, 6, 7. These consist of these 9 records. So this is how the full join would work. So let's now look at subsequent steps. So now we have this third step. So we did A, full join B, full join C. So remember the principle that we articulated before when you have these kinds of multiple joins. You do the first join, that gives you a table, one table. And then you take that one resulting table and you operate the next join. Okay. So here is my intermediate output. So the result of doing A full join B is this table over here. Okay, this one. All right. And let's say that we have table C over here represented by these black dots. So let's go one at a time. So here is A1, B1 in the output, the intermediate output over here is A1, B1. It doesn't match anything in C because you don't see a line from B to any one of the records in table C. So A1, B1 doesn't match anything in C. So in the output, I have A1, B1 null. Okay. Now I look at A1, B2. It matches C2, isn't it? You see this line over here. So here I have A1, B2, C2. Now B2 also matches C3, isn't it? You can see this line over here. So I will, in the output, I will show A1, B2, C3. Here is A1, B2, C3. That's how I get. There is nothing further to match in terms of A1, B2. There's nothing else in C that matches A1, B2. Okay, so I'm done with A1, B2. Now I look at A2, B2, the next record in the intermediate output. A2, B2, B2 matches C2. You see this dotted line over here? B2 matches C2. So here I have A2, B2, C2. A2, B2, C2. Is there anything else that B2 matches? Yes, it matches C3. So I have A2, B2, C3. That's how this output shows up. All right. So now I look at the next record, A3 null. This particular record in the intermediate output does not match anything in table C. So what could I output in the ultimate in the end result? I have A3 null null. Here is A3 null null. Okay. Now I move on to A4. A4 null. It doesn't match anything. There's nothing here from the second column that matches anything in table C. So I would say A4 null null. Here is A4 null null. Okay. Now I move on to A5. Where is A5 should show up over here. I guess we missed a row over here. A5 should also show up as A5 null null because there's nothing which matches A5. Okay. Now let's look at this next next record in the intermediate output. It's null B3. There is no line connecting B3 here to anything in the C table. So in the output, in the final output, I would say null B3 null. There is null B3 null. Okay. In a similar vein, I look at the next record, null B4. There's a line from B4 to C4, isn't it? So B4 is related to C4. The values match. The foreign key and primary key match over here. So the output would be null B4 C4. Here is null B4 C4. Okay. Null B5 C5. Okay. So here is null B. So B5 does not match anything in C5. So I would say null B5 null. So null B5 null. So we are done so far in terms of handling this intermediate output. But I'm not done handling the unrelated records, unmatched records in table C. So you can see C1 over here. It doesn't match anything in the intermediate output. So I have C1 null null. That's this fellow. Similarly, for C5, it doesn't match anything in the intermediate output. So I have C5 null null. That's how this output was constructed. This is the end result. This table is the end result of joining A with B with C, in which case it's given that both of the joins are full joins. So it's a tedious process, but it's mechanically, it's tedious process. The machine will do it for you, but it's a good idea to go through it step by step and just clarify in your mind the matching process. Okay. Okay. Here's a variant of what we just did. So in the previous example, we had A full join B, full join C. Now we again have the three tables, A, B, and C, but the joins are different. We're doing A full join B, but this time join with C. All right, how would the result be different? The result for the first step, A full join B, is the same as before. That's this fellow. So this first intermediate result is the same as before because you can check over here. This is the intermediate result was A full join B. So now we are again doing A full join B as the first step. So the intermediate result is the same. And here is table C. The connections are the same. You see, by the connections are the matching values. They are the same. The only thing different now is we're doing a join rather than a full join. Join means, how would we interpret this join operation? We take the intermediate result, that is the table, that is the result of A full join B. Imagine that it's a table called D. Then I do a D inner join C. So basically what that means, I only look at the values, the records that match. Okay. So here is the output from the full join. So A full join, B full join, C. This is the output that has result. So from this output, I will remove unmatched, anything that doesn't match. Okay. So A1, B1 null. A1, B1 null. It doesn't have a match between the think of the intermediate result as this table over here. Okay, maybe I'll use the pen. It might be easier to identify. Here's the pen. So think of the intermediate result as this table. As this table. This is one table. Think of it as table D and match it with C. Okay, it might be easier to visualize things that way. So this record A1, B1 has no matching record in C. So I remove that particular row. Okay. For the next one, there are matching values, matching values, matching values, matching values. Fine. Now this next record, I have A3 null. This record has no matching values with C. So I get rid of that. A4 has, again, no matching values with table C. So this guy is removed. Now there should be another record over here which is A5 null null, and that would need to be deleted as well. So let's look at the next one. It says null B3. This particular record, null B3, has no matches with any record in table C. Okay. So this fellow is this row is deleted as well, null B3 null. Now if I look at null B4 C, there is a matching value between this record, this intermediate one, and the C table, because you see a line over here. This line means that the foreign key here matches the primary key here. Okay, so this row shows up in the output. So null B4 C4, null B4 C4 shows up in the output. Null B5 null is deleted because there is no connection between this intermediate record and the C table. So this fellow is removed. Lastly, the record called C1 has no matching values with the intermediate result, so this one goes. So C1 is removed. By the same logic, C5 has no matching values with the intermediate table, so C5, this particular record, is removed as well. Once you do all the deletions, the records that you're left with is this one, this one, this one, this one, and this one. So a total of 5 records. So 1, 2, 3, 4, 5. So do you see? Same 3 tables, A, B, C. Full join gives you this result, this guy here. If instead you had a different sequence of join, A full join B, but inner join C, then the result is quite different. It's this small table over here. So I hope you're seeing that the result of the type of join that you use affects the output significantly. It also, you should keep in mind that 90% of the time, the type of join that you will be doing is the inner join. Okay? The left join, right join, and the full join appear, the need to use them appears much less frequently. Okay. Here is another example. Same 3 tables: A, full join B, and then you have the table C, but this time a left join. So what's the difference with the previous example? Same 3 tables. Instead of doing an inner join as the second step, we are doing a left join in the second step. Okay. So A full join B This is the intermediate table. Think of this as the table D. And I'm doing a left join with C. Okay. So just to remind ourselves, how does the left join work? If I'm doing D left join C, then I want everything in D, whether it matches or not, together with the records that match in C. All right. So let's start with the output. I have A1, B1. Okay. Now it doesn't match anything. So here's the output of D. So this is what D looks like. Okay. Sorry, this is the output of the full. Let me take the pen here. This is the output of A full join B full join C. That's the output. Okay. So we use that as a starting point, and from that we can derive what would happen if the second operation is a left join. Okay. So here's A1 B1 null. Now if I look at the first row, A1 B1, it doesn't have a matching value with C. However, if I'm doing a left join, I want all records in D whether or not they match the second table. Okay? So this A1, B1 still shows up in the output. A1, B1 null shows up in the output. Okay. Now I look at the next few values. A1, B2, it has a matching value, C2. So A1, B2, C2, fine, it shows up in the output. B2 also matches C3. So A1, B2, C3 shows up in the output. Okay. Now I move on to A2, B2. A2, B2. B2 matches C2. So A2, B2, C2 shows up here. A2, B2, C2. Now B2 also matches C3. So when I say matches, I mean, again, foreign key equals primary key. So A2, B2, and C3. A2, B2, C3. So shows up in the output. Now I come to A3 null. This is a record in table D, and I'm doing a left join. So I will include this row even though it doesn't have a matching value in C. And how will I express that? I will say A3 null and null because it doesn't match anything in table C. So here you see A3 null, null. Same logic with A4. A4 null, this particular row doesn't match anything in table C. Okay, because you don't see any line between those two. So I'll say A4 null, null. Here is A4 null, null. Okay. So then A5 null should also show up. I don't know how that didn't show up in the output, but A5 null, null should also show up. So now let's look at this one, null B3. This particular record has no matching value in table C. However, we are doing a left join, so we want all the records from the left side table, whether or not it has a matching value. So null B3 null, null B3 null. That's what shows up in the output. Okay. Now, null B4 has a matching value in the C table. These two match. So foreign key equals primary key. Therefore, null B4 C4, null B4 C4 shows up in the output. And then this last one, null B5, it doesn't have any matching value in the C table. But since we're doing a left join, I want all the records from the table on the left, regardless of whether or not it matches. So null B5 null shows up in the output. So I hope you take your time and compare this output with the previous one and the one prior to that. So the three examples that we have had, A full join B full join C, A full join B right join C, A full join B left join C. So three examples of this chain of join. Look at the outputs in the three cases and just convince yourself, just sort of remind yourself as to how we got to those three different outputs, a sequence in which we did the joins method. Okay. So now again, the three tables, A, B, C. The only thing that's different is the second is a right join. So the sequence, first example, both the joins were full joins. The next example, the first join remained a full join. The second join was an inner join. The third example, the first join was a full join. The second join was a left join. So what's left over here? The first join is a full join. The second join is a right join in this case. Okay, so let me go through this one a little more quickly. So we have the intermediate result over here. This is the result. Oops. This is the result of A, full join B, full join C. Okay, so now what is different now is that the second join operator is a right join. And when we do a right join, we want all the records from the table on the right, regardless of whether or not it has matching values on the left, okay, on the left side table. So again, think of this as my table D. I'm doing a right join. With table C. All right. So table C is the table to the right. So I want all the records from table C, whether or not they have matching values. Okay. So let's look at A1, B1 null. Okay. So A1, B1 null, I remove it because it doesn't correspond to a table correspond to the records in C. So this one is removed. Okay. The remaining, the next four values, next four records, A1, B2, C2, A1, B2, C3, A2, B2, C2, and A2, B2, C3, they all are included in the output because these are matching records, okay? So A1, B2, C2, A1, B2, C3, A2, B2, C2, and A2, B2, C3. So those four records are matching. The primary key equals foreign key. Those are matching values, so they show up in the output. All right. So the next few values that show up are records in C that don't have any matching values in D. Okay. A right join means I want all the records from the table on the right. In our case, the table on the right happens to be C. Okay. So here we have C1 and C5. C1 and C5 have no matching values. So I have C1 null null. So I'm saying that here's a record from table C, which is C1. It doesn't have any matching values from the intermediate output. So null null. The intermediate output has two columns. Similarly, C5 is a record in table C that has no matching values in the intermediate output. So I say C5 null null. So that's how what the result is when you have this sequence of a full join followed by a right join. Again, these are four different examples that we saw. It's a little tedious to do the matching, just to follow along as I'm describing. Take your time and review the matching process. It's important to understand how the matching process works, what records get kept and what records get thrown out as a result of the join operation, depending on whether it's an inner join, a left join, or a right join. So take your time and figure out, make sure you understand the matching process of the primary key equal foreign to the matching that you're doing and picking out the records in the output. Okay. So just as a recap of the joins, the result of a join is always a single table. Okay. The table includes all the columns from the two tables. So a join connects two tables. So you have T1 join T2. Okay. So when you do a join, the output is always one table. It never produces two tables as an output. You join two tables, the result is one table. So in the result consists of columns from both tables. So all the columns from both tables get stuck one after the other. Once you get the result, you can start trimming rows and columns. That's a different story. but just the join by itself, all the columns from both the tables show up in the output. Okay. What records show up in the result table depends on the type of join. The outer join tends to give you the maximum number of records. The inner join, the smallest number of records, because it only picks up records that match in terms of primary key equals foreign key. But the inner join is by far the most common type of join that's done. When you do multiple joins, you do one join at a time, and you do the first join, take the result, connect it, join it with the second, with the third table, take that result, join it with the fourth table, and keeps going on and on. Okay. All right. So this is this sort of a summary of some of the major points about the join, and let's wind up with a summary of what we have done here. This is a rather long lesson. So we have learned about how to do querying. We started looking at how to do querying. We started very simple. How do you extract information from one table? How do you do what is aliasing? Why is it there? How do you alias a table? How do you alias a column? How do you show one or more than one column in the output? And then we spent a fair amount of time on joining tables, because if you're going to extract information based on more than one table, you'll have to do at least one join. Okay, so there are different types of join, and we looked at what they were: full join, left join, right join, and then tried to have a discussion of how one goes about joining 3 or more tables. Okay? So the more you practice these things, the better. So I would strongly advise you to go beyond these few examples that we are using to explain the concept. The more you try with SQL Server, SQL Server, the better off you will be in terms of understanding how these different queries work with the select statement. Now, as we said right at the start, the select statement is a workhorse. It has numerous options. Gradually, as you can see, we are starting to learn more and more clauses, more and more options that come with the select statement. There are quite a few more that we will spend subsequent lessons on. But for now, this ends our discussion for this lesson, into discussion on the select statement, select command in SQL for query. Okay.